Hi, it's Terry Dennery of the MathWorks. Anyways, in this video, we're going to kind of go through the steps of integrating our vehicle model with the propeller controls that we just had produced in, I'd say, 2 or 3 episodes ago. All right, and we went through the effort of coming up with a smooth trajectory, and we focused on uh, finite snap and finite jerk to make sure we do not introduce kind of those impossible requests that will lead to instabilities. So, anyways, let's go ahead and get started with this. All right. And so the model we just looked at was kind of as we left it. I think it's probably at least 3 videos ago. And what's going on right now so far is really that we're just taking 1,000 Newton meters of torque, and we're going to drive the propellers with that. So we're going to do a little bit better than that. At least that's our premise. I think I'm just going to move this up. Maybe make it look a little bit better. I think it's pretty good. And well, I'm going to do this. So let's get an out block. Let's see, give myself some more space. Okay, put it like that. All right, and so this could be, of course, XP. So let's just change the name of the block. P, X in, Y in, and oops, YP. I think this is going to work. So let's take every bit of that now, and we'll put that into a subsystem. Just making sure these line up, which they do. All right. And so we pretty much have the same model, and we could do, what we had before, which is constant. And we'll drive them each with 1,000 Newton meters by making that constant value 1,000. Right. And this is pretty close to equivalent to what we had. But you'll recall we introduced that one problem we took on early, which if you're spinning all the propellers in the same direction, well, for angular momentum to be conserved, the whole vehicle will have to spin in the opposite direction. So kind of a cool thing to revisit. And our previous solution was to take a gain we'll make it equal to -1. And at the time, I thought it was a good idea. Well, it's each of these ones that kind of have that, I'll call on the negative end of the beam. Let's make that -1. That's actually a really dumb idea. Yeah, that just, well, I'll just say it introduces an interdependency between the X and Y axes it would be very hard to deal with. I'm sure somebody super clever could figure out how to do it, but I'm not that person. So let's go up here. And so it's better to have them either on the X or the Y. And actually, I think the video we just looked at, I put them on the Y. So let's be consistent with that. And I'll move it there. I'll move that one there. Let's delete that. And so X spins in the positive direction, Y spins in the negative direction. Seem fair? All right. So, well, let's just hit run again. Okay, so again, it's just a constant torque that we're delivering through those motors, and of course they'll spin up to some speed, presuming they're the correct motors with the correct propellers, with the capability to rise this vehicle. And it's just going to go up, and there's no real control to that at all. That's a completely open loop, as we might say, solution, right? So what I'm going to do is just kind of delete these things. I'm going to keep those -1s right there for a moment. We might do it a little bit differently as we kind of work through this, right? Now, here's that propeller test that we did, and it's just the propeller all by itself, and it comes up to speed, right? So it runs very fast. It's already done, and we went through a fair bit of effort to request a trajectory that's very achievable, right? And so that's kind of what we're seeing here, right? And so here's certainly all the mechanics is this, and then we got kind of the aerodynamics is this, and I'd say the rest of it's really kind of controls. So this, 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 and then we made our choice for that trajectory. So I'm going to just copy all that, and I'm going to go back in here, and I'm going to paste it in. And perhaps I should have copied those lines too, but let's just go ahead and go through that again too. All right, and so we have that, and we have the trajectory setting everything, and that this is um, uh, a feed forward component, a calculation of torque required to achieve the I'll call it the aerodynamics to engage properly the pressures that will be formed on that propeller, right? And that ultimately this is a speed controller, and that's looking pretty good. And so I'm going to just take every bit of this and pop it into a subsystem block. All right. And so we're not using Z yet, so I'm going to just delete it. All right. Now this is feedback, called FDBK. This is torque, right? And then we got our trajectory right there, right? So that's looking a little bit better. And I think what I'll do is make this a little bit bigger. All right. And there's a little bit of work to be done still, and especially with these things that were simply given negative torques before, we'll do a little bit with that. All right, I'm going to make this as small as I can, so it'll just fit in nicely. And I think I'm going to do something here, though. And I'm going to say that, well, this is the same calculation for all the propellers, right? And so I'll go Control X. I'll pop this out here, right? Okay. And now we're going to need to have some of these things directly sent in. Okay. Let's just kind of delete that for a second. Okay, and so one of them will be, I'll just call it F for feed forward torque. And this I'll just call WCMD. All right, and that's our controller for right now. All right, so now we got 3 inputs. All right, and but we're kind of getting into the basic idea is every one of these is going to kind of fit with XP, XN, and so forth, each of the propellers. And the basic idea is I want to work off of this, for feedback, right? And so we're going to start using buses a little bit, because what we just sent into feedback has already been defined as a bus. And so if I go to bus selector, well, there it is right there. And so I'll just select that. remove, remove. Okay. And with that, I got kind of my feedback integrated, delivered by what I think leads to nice, clean diagrams with nice, nicely designed signals, right? And then I kind of like the idea of doing this on this side too, right? And so what I'm going to do here is, I don't know, I kind of think of feed forward torque as sort of like a command. We might come up with, different terms as we move through this, but for right now, I'm going to call it that, right? And the basic idea is that we use a bus selector here too, and we set it up, okay? But this truly is not a bus command, therefore this block that reads, connects two buses and then reads what's on there, it knows nothing, right? So we got to go design that, right? And so we're going to design it in here, right? And so we'll get a bus, double click, bus select or creator, all right? And I think what I'm going to do on this is deliver the trajectory whole. So we'll get rid of that selector right now. We're not ready to use that. And that these two probably are pretty good as they are. So let's delete that. And I'll simply call this CMD for command. Okay. And we're going to bring that in there. We'll bring this in here. And then we'll take that trajectory and we'll pop that in right there. Yeah, I did it. Okay. All right. Now again, doesn't know what any of those things are, so we got to tell it. And our way of telling it will be to name the signals. Right. And so this will be, I'll call it W command. And let's say FF torque. And this we will just call the trajectory. Okay, so that's all looking pretty good, right? So now this command is coming in and I can send it in right there and it knows what it's looking at again, right? And so come in here and we will get, I'm gonna do feed forward torque first and W command second, and I'll remove that. And I want feed forward torque because it's connecting up here and I don't want my lines to cross, and W command right down there. Okay, so that's looking kind of good, right? And now I think it's just a matter of doing that a few times. All right. Right. And notice we're really kind of depending on the symmetry of what's being asked. Essentially all four motors are being asked to do the same thing. And I'm kind of letting you know where this will go will be that this block will get a little bit more sophisticated. And certainly in the previous video, I already let you in on that this will essentially evolve into the flight controller itself. So anyways, let's go ahead and finish doing this. Okay, and I'm going to even get rid of these for right now because I want to actually contend with the problem when it really is encountered. All right, so let's tap into that, get these feedback loops. Okay, So you can see it is rotating again. And at 10 seconds, it's supposed to start lifting. And so let's see if that happens. 9, 10. And it does. Okay, good. So I'm absolutely encouraged by that. So let's just kind of fix the problem with it rotating as it is. All right. Oops. Not using that model anymore. I'll even close it. Okay. And the basic idea of this is to get the propeller to spin in the opposite direction. And that will lead to a negative torque. But kind of the way to do this is this generic speed that's being delivered to all four is that kind of locally make that choice that it's going to be minus. And so we made the choice that we want the y's to be negative. All right. And here's how I want to do it. All right. And so I take all this and just kind of give myself some real estate. All right. And let's happen to have a -1 right there. So I'm going to use that -1 right now. Okay. And actually, here's the way to really do it. Okay, let's give myself some room this way. Prop direction. Okay, the block glows in pink, and so we got some work to do. All right, so I'm going to just hit Control C and grab that. And we will create a mask, and we'll just make it a masked parameter. Go in here, propeller direction. I'm going to give myself a little reminder, 1 or -1. And that parameter will have the name of that MATLAB variable that we just introduced. And so I hit save. And I'll make that -1. Okay, and so again, we're going to do these on the y's, so I'll delete that. All right, and here, even though these are going to be positive ones, it's kind of a good idea to have a nicely formatted component that's kind of operating the same way for each of its instances. So that's why I'm going to come up here and we'll make their values 1. Something's bugging me about it kind of slowly rotating. We're not at 10 seconds yet. Okay, so that we might discover we got a little bit of work to do there. I'd say that most likely, well, it's either I could go track down a bug that I didn't know was there, but I'd say that again, it's not precise on kind of controlling each of those propellers perfectly, and it's almost like I'd say in this example, it's almost like numerical error buildup in the computation might be slightly different, and it might be leading to a rotation. But I'd say the more what do you want to call it, philosophical, deeper kind of consideration of feedback controls is that there's always something that you can't exactly um, understand perfectly or anticipate properly, and therefore you apply feedback and you deal with stuff like that. So, anyways. I think I'll stop this video right now. And in the next one, we'll put in uh, the feedback loop that I showed in the previous video that will kind of address what we just saw. And in the next video, we'll run it for 120 seconds and make sure it gets up to the 2,000 meters, which is what our trajectory is asking for. So anyways, thank you.